A warm welcome to all viewers. In this class, we will learn about correction to basic runway length. I am Ashok Kumar, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. At the end of the session, students will be able to calculate the runway length with applying the various corrections. As we already learnt in the two sessions, the actual runway length includes the basic runway length plus the corrections. So in this case, already the basic runway length already we have calculated by applying the various methods. That is, the aircraft is landing normal condition, takeoff condition, and engine failure conditions. Now we are going to apply the various corrections and calculate the actual runway length. So actual runway length is calculated by applying three corrections, namely elevation correction, temperature correction, and gradient correction. As the density, air density reduces as we go higher and higher altitude, because of this, due to this reason, so the air pressure and air density reduces and your temperature also reduces as we go higher altitude. And due to that, the liftoff will be lesser in this case for the aircraft wings. So that is the reason we apply the correction of this elevation and temperature and increase the length of the runway. And gradient correction, already we know that as the steeper the gradients are there on the runway, it requires the additional energy or additional power to aircraft to move or aircraft to go into the air. We require to have additional length. So that is the reason the steeper gradients also are not advised on the runway. So applying these three corrections, we are going to increase the length of the runway. Now we'll solve some numerical examples to understand how we are going to calculate the runway length of after applying these corrections. So already we know that the various corrections, their rates. For the elevation correction, we know that it's 7% for 300 meter rise in the above MSL. Whatever the given elevation for above the MSL, we need to take the consideration and calculate the appropriate correction length. And temperature correction, after correcting the elevation correction, we are going to apply the temperature correction. That is 1% for every 1 degree rise in the airport's reference temperature. And combining these two, so we should also know that the length which you additional length you have calculated, that should not be exceeded more than 35%. After correcting the elevation and temperature, we will apply the gradient correction, that is for 20% for every 1% effective gradient. Now the example is given like this. The airport is located at the MSL level, so it means exactly at the MSL level the airport is located, and the ART temperature is given to, that is airport reference temperature is 32.6 degree. Apply the temperature correction to the runway length and calculate the corrected runway length. So here what we are going to observe here, it is exactly at MSL. So it means there is no elevation it is given. So it means the airport is exactly at the MSL level and the ART is given to. So now we are going to proceed like this. So first only the temperature correction it is asked over here. So because of that, and that airport is located at the MSL level, so there is no elevation correction will be there in this case. Now only applying the temperature correction, we should be able to find out what is the corrected runway length. Now at MSL, the standard atmosphere, the standard temperature at the MSL, already we know that it is a 15 degree. It is taken as the standard temperature at mean sea level. And what is the difference in the temperature? ART minus the standard temperature at the elevation of the mean sea level. So that is 32.6 minus 15 degrees. So 17.62 degree is the difference in the temperature. So here let the runway length be the L meters. So the original length of the basic runway length is not given. So let us try to assume that the basic runway length is L in meters. Now applying the temperature correction, that is 1% for every 1 degree rise in the ART temperature. So this different temperature over here. So 17.6 degree, how much is the rise in this correction? So for 1%, this already we know this. So that is 1% for every 1 degree rise in the ART temperature. So 1% for every 1 degree rise in the ART temperature. So for 17.6 degree, how much is the the correction over here. So that is we have done here. L is taken as the original length of the basic runway length. So 1% for 17.6 degrees. So in that case, it comes to 0.167 6L, 0.176L, and now the L is unknown factor here. So this is L plus 0.176. So that comes to 1.176L is the corrected length after applying the your temperature corrections. Now you take a pause over here and try to give the answer for this. The effective runway gradient is given as 0.5%, and what is the runway length after applying the your gradient correction? So here the runway is already corrected for elevation and temperature, and that length is given as 2845 meter. So only you need to calculate the what is the gradient correction over here. So for that they are given the 0.5% is the effective gradient. So I hope you are able to know that. We know that what is the correction we are going to apply for the gradient correction. So out of these 4, I hope you are able to calculate the correct answer. The correct answer is, so we know that 20% for every the rise of your effective temperature. So in that case, so it is 0.5% is given as the effective gradient. So for that, for 2845 meter, how much is length? So for that, it is 284 meter is the effective gradient, and you apply the 284 plus 2845, that comes to 3130 meter. So this already we know that in the previous slide, this is 20% for every 1% of the effective gradient. So this is we are applied and calculated this the correction over here. So for 0.5%, how much is that in that case? So 20% multiplied by 0.5 into original length of the basic runway length is 2845. That comes to 284 meter, and add this 284 meter to the basic runway length, that comes to 3130. So option number C is the correct option. Now the second case, we have the elevation is given to 170 meter is the elevation is given to you, ms above the mean sea level, and basic runway length is given as 2100 meter, and ART is also given to 32.6 degrees given to you. So asking you to, and effective gradient is also given to you. So knowing the table, you should able to write this all the correction. 7% for 300 meter rise, 1% for 1 degree, and 20% for 1 degree, 1% of effective gradient. So you should able to calculate and adding these two, the 35% should not be, the increase in length should not be more than 35%. If you know this, you are going to calculate the runway length applying these 3 corrections. Let us try to solve that example. Now first one, elevation correction. So we know that 7% for every 300 meter rise in the elevation. So the original length is given to you 2100 meter, and for 170 meter elevation, what is the rise in the correction is required? So it is for 7% for 300 meter rise in the elevation. So for 170 meter, what is the correction is required? So calculate the x. So that is whatever done over here, and multiply by the length of the basic runway length is 2100. So that comes to 83.3 meter is the length you are going to get it. Now corrected length after elevation correction is 2183.3 meter. Now go for gradient correction here. Temperature corrections. So the temperature correction, the elevation is given 170 meter. So first you calculate what is the standard temperature, that is ST value at mean sea level. So standard temperature is taken as 15 degree, and the rate of decrement of the temperature as we go at higher altitude, that is minus 6.5 degree centigrade for every 1000 meter. As we go higher, for every 1000 meter rise in the elevation, you are going to get a minus 6.5 degree. So it is 6.5 divided by 1000, that comes to 0.0065. So multiply 0.0065 into the elevation and deduct it with the standard temperature at the mean sea level. So that comes to 13.9 degree. Now for the temperature correction, you have to calculate what is the rise of temperature above ART, airport reference temperature. So airport reference temperature is given as 32.6 minus this 13.9, that comes to 18.71. That is the rise of the temperature. For this, we are going to apply, that is 1% for 1 degree rise in the airport reference temperature. So for this, we are going to apply that 1% for 1 degree for 18.71. How much is the length? So in that case, 18.71 into 1 by 100 multiply by this 2183, that is after applying the correction of elevation, we have got the 2183. So with that, we have got 408.3 meter is the corrected correction for the temperature. Now we are going to add 2183.83 plus 408, that comes to 2591.6. This is after applying the correction of our temperature. Now we should know that, already we know that the rise in the or increase in the length of after applying the correction for temperature elevation should not exceed more than 35%. So for that, we should know that increased length is 2591 and basic length is 2100 meter. So take the deduction of the difference of that and divided by the original length. So into 100. So this is 23.4 is less than our 35%. So hence it is less than 35%, hence it is okay. So it is below 35%, hence it is okay. The last correction is our gradient correction. So effective gradient is given to you as 0.23%. So already we know that 20% for every 1% of the effective gradient. That is the rate, we already know that. For 0.23%, how much is the effective gradient correction is required. So for 0.23, multiply by 2000 and corrected length after gradient and elevation. So that comes to 119 meter. So add the 119 to the runway length after corrected of temperature and elevation, that comes to 2710.81 meter. So here the rounding up to, it will come to 2720 meter. So this is how we apply the correction of elevation, temperature and gradient. I hope so this video is useful for all of you and you understood how to calculate the runway length with applying these corrections. These are the references I have used for preparing the presentation. Thank you.